Hello, my amazing students. We are starting 8.2, which is adding and subtracting rational expressions. And just like when you learned fractions the first time, we always did multiplication before we did addition and subtraction because it's just a little easier. You don't have to find a common denominator. But now we're going to be finding least common denominators. And at this first part, we're not actually adding them together. We are simply finding the common denominator between 14 and 20. And we're going back to regular fractions just to refresh on the mechanics of finding a common denominator. So, although you could probably do this one in your head, let's just look at the process. The process is to factor each denominator into its prime factors. When I talk about the prime factors, that means the factors that are prime, you cannot divide them by anything else. So, although 14 is 2 and 7, 2 times 7, and that's all we can do, 20 is 2 times 10, but 10 can be factored again as 2 times 5. So the prime factorization is 2 times 2 times 5, or 2 squared times 5. Okay, so once we have gotten the prime factorization of each one of the denominators, then we're going to build the LCD, and the LCD is always going to have all of the factors represented, and the factors have to be complete so that you can see each one of the individual denominators, but they can share factors. So in other words, I've got to have a 2 times a 7. Okay, I'm going to move the 7 over. Usually when we write a common denominator, we write it in ascending order from smallest to greatest. So I'm going to write down the 2 and the 7. Then when I get over here, I've got a 2 squared. Since I have 2 2's in one denominator, I must have 2 2's in my LCD. So I'm going to put a 2 squared, and I need a 5. So the smallest number that both denominators will go into is going to be 4 times 5 is 20, times 7 is 140. And that's something that you probably could have seen. But as we get into more complicated rational expressions instead of just fractions, we're going to find that we need to do this process every time. Factor each denominator, build a least common denominator. Now, we're not actually getting equivalent fractions at this time. Right now, we are just finding the common denominators. So here we go on with the next one. And in this one, we have, if I were going to prime factor this one, I usually just prime factor the numbers because, of course, w to the 4th is w times w times w. That's already factored. And then 5w squared. So when I am going to make my LCD, it is going to have a 3, because that's the smallest factor, times a 5, and a w to the 4th. Now, 5 goes into the 5 that's already there. They can share, and w squared is inside w to the 4th. So, this is my least common denominator, which is 15w to the 4th. So 15w to the 4th is the smallest denominator, and we're done with that one. Okay, so this is two rational expressions, 3 over d and 11 over d minus 4. So now we're going to build the least common denominator, and neither one of these factor. They are already prime. Therefore, I'm going to have d times d minus 4. All right, so now we are working on our least common denominator on this one. So we're going to have our, well, hello. And excuse me, now we're going to get back to our least common denominator, and this is, first of all, this is already factored, so now we're going to have this one, t supper, huh? Okay, so t, and then we're going to have another t. My daughter is having fun getting ready for costumes here. Okay, so since 40 can factor as a 4 and a 10, those will add together to give you 14. So t plus 10 plus 4. And so we factored this one, and when we FOIL it back together, we get the right denominator. And now we're going to build our LCD, which is going to be a t plus 4 and a t plus 10, and the t plus 4 can be shared. So this would be the complete LCD for that problem. Okay, so now we have this denominator could be 2p factored out, and we get a p minus 3. On the other side, we have a p minus 3, p minus 3, and a p plus 6. So when we have the, we get the negative 18 and a positive 3p. So now that I've factored each one, I will go through and make the LCD, which has got to have a 2p. It's got to have a p minus 3. This one over here has to have a p minus 3. But since this is in two separate denominators, one p minus 3 can be shared by both. And it's got to have a p plus 6. So you should be able, in your LCD, to completely see each denominator. I see a 2p, I see a p minus 3, so this denominator is represented. And then I look over here, yes, I have a p minus 3, yes, I have a p plus 6. This denominator is represented. It does not matter that they're sharing one of the terms. No big deal. Okay, so go on to the next one. And since this is an f minus g and a g minus f, we can multiply 1 by a negative 1. And so what I would do here is I would take one of these and I would multiply by negative on the top and the bottom. And so now I have one denominator. So the denominator, when I multiply the negative through there, is going to be g minus f. And my LCD would be g minus f. And the only thing I need to do is multiply one of them by negative 1 over negative 1 to get both of them represented over the same denominator. So now what we're going to do is actually start not only finding the least common denominator, but also re-expressing each one of the rational expressions over the new denominator. And we call these equivalent rational expressions or equivalent fractions because they mean the same thing as the original, but now they are over the common denominator. So this is a two-step process here before we move on to actually adding and subtracting them. So this one would factor as 2 times 5 times x. And this one would factor as 5 times x cubed. So my least common denominator is going to be 2 times 5 times x, 2 times 5 times x. And then this one has a 5 squared. So I am going to need a 5 squared. Since one denominator has 2 5s, I need to have 2 5s present in my least common denominator, and then I need to bump this x's exponent up to 3 so that I can see the 2 5x, and I can also see the 5 squared x cubed in the denominator. So here's my LCD, and now I'm going to say, okay, what is missing? I'm going to write this one over here just a little bit because I need a little bit of room. So I'm just writing this, sliding it over a little bit, and we're talking about now equivalent fractions or equivalent rational expressions. So now I'm going to multiply by 1 in some form in order to get the common denominator, and this is where I look for what is missing. What is missing between the old factors and the new factors I'm trying to get to? I've got the 2, I need one more 5, and I need x squared. So I'm going to multiply by 5x squared over 5x squared. Okay, and then on this other side, what am I missing between the old and the new? So I've got only the 5 squared, x cubed. I'm only missing the 2. So I'm going to multiply this one by 2 over 2. Okay, so let me get another board here so that I can finish that problem up. Erase an old one. So now I had, in this first one, okay, I had 45x squared on the top. So I'm going to write that right here, 45x squared. And on the bottom now, I have the least common denominator because I multiplied by what's missing. So the least common denominator is going to be 50x cubed because that's what 2 times 5 squared times x cubed winds up being. So then the second part over here, when I multiply 6 times 2, I get a 12 over 50x cubed. So the second one is 12 over 50x cubed. And now look how, if now I have the 2 rational expressions redone, so this is the new one, to where they are both over the same denominator. Okay, so let's see if I can hold these with one hand. Okay, so can you see how this one would reduce to 9 over, hold on, let's see. Yeah, 9 over 10x. This one would reduce to 9 over 10x. And the other one over here would reduce to 6 over 25x cubed. Okay, so this is why usually when I do these, and you'll see me do it in the classroom, instead of writing them like this, I will write them as 45x squared over LCD and 12 over LCD until I actually get them added or subtracted, because some of my best students are so diligent about looking at their problems that they will accidentally reduce before they add or subtract. So you will often see me, instead of writing 50x cubed, I'll just write LCD, because I always write down LCD and circle it. So basically the steps involved are factor your denominators, build your LCD, multiply your original fraction by what's missing between the old denominator and the new denominator. Do the same thing for the other rational expression or fraction. Multiply by what's missing between its factors and the LCD. You're always multiplying by 1, so you never change anything. And then when you look at the new rational expressions up here, don't they mean the same thing as the original rational expressions? We're going to be working on that a lot in the time to come. So here is one more. Okay, so we have a d over d minus 4 and an 11 over 4 minus d. Since I recognize these two as being negatives of each other, I'm just going to go ahead and change this one. Since this one is in descending order, I'm going to leave it alone. And then this one is not in descending order, so I'm going to basically multiply by a negative and a negative. So I'm multiplying by 1 in the form of -1. And so I've got d over d minus 4. I don't have to touch that one at all. I get -11 over negative times negative is positive, -4. So now I have two rational expressions all ready to add or subtract. So I'll be back with more in a moment. So here's another one that we're going to do. And notice that neither one of these denominators will factor. And so we're going to have to build the LCD. C plus 4, C minus 9. The LCD is going to be C plus 4 times C minus 9. Okay, so when I go to multiplying each one of these by 1, the form of 1 that I'm going to use to multiply this first one by is going to be what's missing between the old denominator and the new denominator I'm trying to get to, which is C minus 9. So I will multiply it by 1 in the form of C minus 9 over C minus 9. And then over here, I will multiply by 1 in the form of C plus 4 over C plus 4. And now my final result will be 3 times C, 3 times -9 over the LCD, which is C plus 4, C minus 9. And C times C is C squared plus 4C over the LCD, which is C plus 4 times C minus 9. Now we're actually going to begin adding together our rational expressions. So here we have 2/3 plus 5/3. And since we have the same denominator, remember what we do with fractions. If we have the same denominator, all we have to do is add the numerators and get 7/3. That's so hard. Okay, so here we have 4C plus 3 on both denominators. So I am ready to subtract, but I do have to remember, since I have a two-term numerator over here behind the minus sign, that this minus sign is like a -1 distributing through. So when I put all of that together with the minus sign, it's going to be 6C minus, that's a -1 times, so minus 3C minus 2 all over 4C plus 3. So that one would simplify to 3C minus 2 all over 4C plus 3. So that one is done. Pretty easy when you have like denominators. So this one is a 13 over 7a minus a 6 over 7a. And since they are the same denominator, I am free to go ahead and subtract the numerators. And I get a 7 over 7a, which will reduce to a 1 over a, because the 7 and the 7 will cancel, leaving a 1 over a. All right, so this is the last one we're going to do with common denominators already done for us, because the rest of them we're going to have to do that ourselves. So we have a k times k minus 3 and a k times k minus 3. We do have a minus sign, so we're going to have to be careful to distribute this minus sign to both of the terms of the denominator of the numerator following the minus sign. So we're going to have k squared minus 15 minus 12. Negative times negative is positive 6k. So this negative has to be distributed. That is a very common error. So I put it all over the common denominator. And now I need to simplify a little bit. This numerator is k squared plus 6k minus 27. And that's all over the denominator, which is k times k minus 3. Okay, so I end up with this, but because 3 does go into 27, I have at least cause to think that possibly this will reduce further. So I'm going to factor the numerator and see if k minus 3 is a factor. I'm going to suppose that maybe it is, which would mean that k plus 9 would be the other factor. So I'm going to FOIL that together, and I get a k squared minus a 3k plus a 9, so I do get the 6k minus 27, so that is correct, all over k times k minus 3. So now, can you see that? I'm going to pull it up closely. So now that I've factored the numerator, I can see that I have a k minus 3 in the numerator, a k minus 3 in the denominator, which I should cancel. And then I wind up with the whole problem being equal to k plus 9 all over k. And I don't have room to write that, but I would write just k plus 9 over k as my final answer. And now we will start to add and subtract rational expressions that don't have common denominators. Okay, so now we're back with problems that do not already have a common denominator. And this one's pretty simple because we can see that this one is a 5 times a 2. So all we need to do is multiply this one by 2 over 2, and the two denominators will be the same. So I'm going to move my plus sign over just a little bit. I'm going to put my 2 over 2 right there. And now my equivalent expression is going to be 2 times q minus 6 all over 5 times 2 is 10 plus q plus 6. Now this one over here does not need to be changed because it already has a 10 as a denominator. So q plus 6 over 10. I can just write that one down. And now, since they have the same denominator, I'm free to just go ahead and add. Since we have a plus in between, there's no distribution necessary. Look at this one, negative 6 and a positive 6. They go out, and I get a 2q plus a q, or simply a 3q over 10. And that should be the answer to that one. And 3q over 10 is correct. The next one that we're going to do has a 9m and a 12m to the 7th. So 9 is 3 times 3, and 12 is 3 times 2 times 2, or 2 squared. And they both have an m and an m to the 7th. So my least common denominator has got to have 2 3's and an m. So it's going to have a 3 squared and an m. But the second denominator has to also have a 2 squared times a 3 times an m to the 7th. And so now that I've figured out my least common denominator, I'm going to have to multiply each one of these by whatever's missing to get them in the right form. So on this one, between these old factors and these new factors, I am missing a 4, and I am missing m to the 6. So I'm going to just squeeze this minus sign a little bit and multiply by 4m to the 6th here, 4m to the 6th over 4m to the 6th. Try to write real tiny, 4m to the 6th over 4m to the 6th. And my new expression is going to be 32 m to the 6th over 36 m to the 7th. Okay, minus, and then over here on the other side, we've got what's missing. We've got a 3, we need another 3. We've already got the 2 squared, and we've got the m to the 7. So all we need is a single 3, so I don't need quite that big a, so 3 over 3. So this one is going to be minus 33, excuse me. 11 times 3 is 33. And then I have my LCD on the bottom, which is 36 m to the 7th. Okay, and like I said, usually I'll just put LCD instead of take the time to write that down there. So my answer is going to be 32 m to the 6th minus 33, all over here. And again, I'm running out of board. All over 36 m to the 7. So 32 m to the 6 minus 33 over 36 m to the 7. So the next one, okay, we have 2 different denominators, but if you're aware, if you're looking, k plus 4 is inside this one, because when we factor this one, we get k plus 4, k minus 4, okay, and so since this one fits into the other one, this one is my LCD. Okay, so this is my LCD. This one is already over my LCD, so I don't have to do anything to this one to get it to be equivalent. This one I'm going to multiply by what's missing, and what's missing is a k minus 4, but I always multiply by 1. K minus 4 over k minus 4. So now when I rewrite my rational expressions, I've got a 3k minus 20, because nothing happened to that one. And I'm just going to write LCD because I'm a little bit lazy. And then I'm going to distribute here and get a k squared minus 4k over the LCD. So now, since I have everything over the LCD, I'm going to go ahead and do the math on the numerator, which is going to give me k squared plus 3k minus 4k. So I'm going to have a k squared minus k minus 20 all over the LCD, okay? And let's think if that's going to factor at all, and I think it is. So let's take this one here and factor this. So I'm going to go ahead and just erase this right now so that I have a little bit more board space. And I'm going to rewrite this k squared minus k minus 20 over the LCD, which is k plus 4, k minus 4. And now this numerator is going to, it's got a minus here, so we're looking for a difference. And I'm going to use 5 and 4 because the difference is 1. So we're going to have a k and a 5, a k and a 4. We're looking for a minus in the middle, so it's going to be minus and plus over k plus 4, k minus 4, And when we're done, these will cancel, and we are left with a k minus 5 over a k minus 4. So our final answer is k minus 5 divided by k minus 4. All right, so now, this one looks fun because we're going to factor two denominators completely. Okay, so on this one, the denominator is going to be an n and an n, and a 4 and a 3, and a positive and a negative. Okay, so that's the factors of this first denominator. The second one is going to be an n and a minus 5n plus 4, because again, the difference is 1. And then my LCD is going to be n plus 4, because I have both of those there. It's going to share that one, n plus 4, n minus 3, and n minus 5. So we have a 3 parenthesis LCD. Okay, so now I'm going to re-express this one over this new denominator. And I have to think about what's missing between here and here. So these factors are here. So I got the n plus 4, I got the n minus, so I'm missing the n minus 5. So this one is going to be multiplied by n minus 5 over n minus 5. And I'm just going to write it there, and we'll get another board in a minute and do this. Okay, this one is an n minus 5 and an n plus 4, so it's missing an n minus 3. So I'm going to multiply this one by 1 in the form of n minus 3 over n minus 3. These boards are just so small. Okay, so I'm going to go get another board here and erase what's on it so that I can re-express these two a little bit. Oops. I'm going to throw them on the floor. Okay, so now I've got 3n over n squared. I'm going to just put times n minus 5 over the LCD minus n plus 6 n minus 3 over the LCD. Okay, so see what I've done here. This is what we had before, okay? And now I'm just simplifying it. And then I'm using LCD to represent all of those things. So 3n times the n minus 5. So that's what I have there, over the LCD, and then minus in the middle, n plus 6 times n minus 3. Okay, so when I distribute these out, I'm going to get 3n times 3n squared minus 15n, and then I'm going to go ahead and distribute this, so I'm going to leave this minus out for a minute. So it's going to be an n squared plus 6n minus 3n is plus 3n minus 18. And now when I distribute that through, I'll have 3n squared minus 15n minus n squared minus 3n plus 18. And all of that's over the LCD. And then I simplify. So 3n squared minus n squared is just 2n squared. So that goes out and that goes out. And then I've got a negative 15n, and a negative 3 is a negative 18n. And then a plus 18. So those go out. All over the LCD, which is, I'm going to bring that back now, n plus 4, because I have it on the other board here. N plus 4, n minus 3, n minus 5. Okay, now this does factor out a 2, okay, But when you factor out a 2, you end up with a 9 here, and it does not factor anymore. So this is actually the answer that the book gives right there. Okay? And I will be back with more in a minute. Right, so now we are finishing up 8.2 with our denominators that are actually negatives of each other. So what I would do here, since this one is descending order, I would go ahead and change this one by multiplying by a negative on the numerator and a negative on the denominator. And when you do that, now you end up with 2r plus 4 over r minus 4. And that is the answer, because that does not simplify. You could pull out a 2 on the numerator, but nothing would happen to it. So this is fine. And the last one for the section is going to be, this one I would multiply by a negative on the top and a negative on the bottom. When I multiply by the negative on the bottom, it turns around. You can show it if you want to there. Okay, and then over here, this one is becoming r minus 4, r plus 4. When I factor, therefore, since this denominator is inside this denominator, this one right here is my LCD, which means that this first rational expression will be multiplied by what's missing, which is r plus 4 over r plus 4. So we got r plus 4 over r plus 4, which is going to be negative 4 times r plus 4, and then plus 9 all over the LCD. So when I simplify this, I'm going to wind up with, I used too much space, but negative 4r, and then negative 16 plus 9 would be negative 7, all over the LCD, which is r minus 4, r plus 4. Okay, and so when I finish that up, I get negative 4r minus 7 over r minus 4r plus 4. And we'll pretend that I wrote that out. Okay, so negative 4r minus 7 over r minus 4r plus 4. And that is the end of 8.2. And I will be back in a little while with 8.3. This is Mrs. A, and may God bless your day.